Let's take a look at this problem. We've got y minus 1 squared equals negative 12x. And we want to find a vertex, focus, directrix, and the graph. So we have to see which one this matches. We've got two formulas. Top one, the square root is on the x. The bottom one, the square root is on the y. Well, in this problem, square root is on the y. So it matches our bottom formula. Now our bottom formula says y minus k squared is equal to 4p times x minus h. Now this is fine over on the left side. We got y minus or y plus a number squared. But over on the right side, we need parentheses before the x. And we can always factor out whatever number's in front of our x. So I'll factor out a negative 12. Now, we need to rewrite that negative 12 as 4 times something. And that's pretty easy. 4 times negative 3. And we want to rewrite this as x minus or x plus a number. And if you just have a single variable, you always rewrite it as x minus 0 or x plus 0. And now it's in standard form. Now whatever numbers with our y's are k, and it'll always be opposite sign. So this is a negative 1, so k is equal to positive 1. Whatever numbers with our x is always our h, and it's opposite sign, though 0 doesn't have a sign. So h is 0. And whatever numbers inside our parentheses is our p, so p is negative 3. Now working with the bottom formulas. Now no matter what, your vertex is hk. So h is 0 and k is 1. Now our focus for the bottom formulas. Focus is h plus p comma k. So h plus p comma k. H is 0 plus p is negative 3, comma k, which is 1. So I'll be negative 3, 1. Our directrix is x equals h minus p. Well, h is 0 minus p, which is negative 3, and a negative negative becomes a positive, so we got x is equal to positive 3. And let's go ahead and sketch those. Vertex is 0, 1, which is right there. And our focus is negative 3, 1, which is right there. And our directrix is x equals 3. So it's going to be a vertical line at 3. Now we want to plot some points. So I'll drop a point here, and I'm eyeballing the distance between that point in the focus and that point in the directrix. Now I want them to be the same, more or less. That's probably not too bad there. I have a hard time eyeballing these. But that distance from the focus to that point should be the same as that distance from that point to the directrix, forming a 90-degree angle. We want another point. That's as good as I'm going to get. Again, that distance from the focus to that point should be the same as that distance from that point to the directrix, forming a 90-degree angle. A little bit longer here, I think, but oh well. After you get 2 points, you know it's got a parabola shape. It's got a curve. So it's going to look like that, more or less. And then I can flip it over, and by symmetry, that tells us it looks like that. And that'd be our graph.